Hello everyone, welcome to the lecture series Design of Digital Circuits. So in this today's session we are going to see about the digital and analog basic concepts. So in this previous session we have seen about the fundamentals of digital system. So here we are going to see about basic concept of analog system like the continuous signal. So analog system processes continuous signal that vary smoothly over a time period, representing the physical quantities like sound, light or voltage. So these signals can take any value within the range, mirroring the real world phenomena directly. So the main characteristics of this continuous signal are infinite in resolution, meaning they can represent suitable changes. For example, a voltage fluctuating in between something 2.1 to 2.0 volt. Likewise, so however, they are vulnerable to noise, temperature change, and component age. Component aging, which can distort the signals. So the main application of this continuous signal found in traditional devices such as analog radios, record players, and then mechanical gauge, so where the output is a direct analog of the input. This recorders, we take it as example, the needle movement follows the grooves continuous variations to produce the sound. So the analog systems requires precise components to maintain signal fidelity, so making them prone to errors and less suitable for applications needing high accuracy or data storage. So these are all the basic concepts as analog system. So here we are giving the figure, that is circuit diagram, and we are moving to the digital system. We are using the discrete signals. So digital systems process discrete signals which represented by the finite set of values, like binary values, that is zeros and ones, in ways explained in the previous session. So these signals are created by sampling and quantizing the continuous data at a specific interval. So these discrete signals have fixed state, making them robust against noise and degradation. For instance, a binary signal remains 0 or 1 even with minor voltage fluctuations, ensuring the reliable data transmission the processing. So power modern devices like computers, smartphones, smartwatches, like digicams, that is digital camera, and streaming devices, so where the data is stored and manipulated as binary bits. So for example, a digital photo is stored as a grid of discrete pixel values. So the main advantage of this discrete signals enable error corrections and data compression and precise computations, making digital system ideal for complex repeatable tasks in computing and communications. So by comparing the analog voltmeter and digital voltmeter as shown in the circuit diagram, so we are using the meter movement. Here we are using the digital display. So an analog voltmeter measures voltage by moving a needle across a continuous scale, where the needle position corresponds to the output. Maybe the needle position correspond to the input voltage we are giving. So it relies on magnetic or mechanical components, making it sensitive to calibration of the errors, vibrations, or parallax when reading. So we consider the digital voltmeter, which converts the input voltage into a digital signal using an analog to digital converter, that is ADC. We are giving in the block, right? So analog to digital converter, and displays the result as a numerical values on a screen. So it offers high precision and clear readability, often with additional features like auto ranging. So the main key difference for the both analog voltmeter and digital voltmeter is this analog voltmeter provides a visual continuous indication but less accurate and harder to read precisely. So the digital voltmeters deliver exact discrete values, are less affectionated by external factors, and can incorporate error checking mechanism. So the main significance of this comparisons highlights the practical benefits of digital system in measurement applications, emphasizing the accuracy and ease of use over analog limitations. So we take for the betterment of the system, we use the digital voltmeters. So main advantages of digital circuits over analog is we can segregate as 3 points. It may be a reproducibility of the results. So digital circuits ensure consistent outputs for the same input because discrete signals are inherently stable against noise and minor variations. This reproducibility is critical for reliable systems like digital storage or communication. So a digital music file played on different devices, we take it as a example, so which produce the identical sound quality, whereas analog tapes degrade over time, altering the playback. Actually, we consider another one as simplified design process of this digital circuits with the flexibility and functionality. So digital circuits are easier to design using the standardized components like logic gates, microprocessor, and design software, reducing development time. So they offer flexibility as a single digital chip can perform the multiple tasks by reconfiguring its logics. So for example, a digital signal processor can handle audio, video, or sensors data with the same hardware, unlike analog circuits, which often require dedicated components for each functions. So we take as a programmability, these digital systems can program to adapt their functionality through software or firmware updates without modifying the hardware. So for example, we take it as a smartphone operating system can be updated to add new features, while an analog radio's capabilities are limited to its original design. So these are all the main advantage of this digital circuits. Added on advantages is it is a superior speed and then cost effective and technological advancements. For this, we can take an example of modern CPUs, so which process billions of instructions per second at a lower cost than analog equivalents, enabling affordable high performance devices like laptops. So